Hello everyone, myself Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating Systems. So we are learning about the basic concepts of operating system. In up to our last lecture, we learned about introduction, and definition to the operating system. We understood what are all the services provided by the operating system. We understood the different types of operating system, functionalities of the operating system, and also we understood what is user mode and kernel mode of the operating system. And also in the and also we have understood the different interfaces that are available whenever we want to request the operating system to perform a specific task. Okay, so in today's class we'll see about system calls. Okay, now what is the use of this system call? See, in the last class we understood about user mode and kernel mode. So sometimes we want to move from user mode to the kernel mode. Why? In which situations we want to move from user mode to kernel mode? I'll take same one more example. Suppose you want to perform an operation of 4 plus 5 plus 6. Now to perform this simple task, no need to move to the kernel mode. Directly we can perform the operation in the user mode itself. Isn't it or not? That means user can perform this task. But suppose if you want to print the output on the monitor. Okay, if you want to print the output on the monitor, under whose control the monitor will be? The monitor is under the control of operating system. Isn't it or not? That means the user cannot directly access this monitor. The user has to request the operating system, then only the operating system, like through kernel, we will be getting the monitor. That means in that case, we need to move to the kernel mode. So in detail about how this, what is user mode and kernel mode, you can go through that lecture that is already uploaded. You can go through that lecture. Okay, now coming back to the system call. Now what is the use of the system call? So whenever we want to move from user mode to kernel mode, that means whenever we want to switch from the user mode to the kernel mode, then programmatically we can do that one by using, that is called as a switch case. That means that is called as a system call. Okay, so the programmatic way to switch from user mode to the kernel mode is called as a system call. And if you want me to write down a definition for the system call is nothing but an interface to the services provided by the operating system. So we have so many services. Let us consider monitor is under the control of operating system. The user want to use this monitor. Now user has to request the operating system. How the user has to request the operating system? Through the system call. That's why the system call is called as an interface to the services that are provided by the operating system. I hope you all are clear now. So now like normally or this like typically these system calls are developed in the high level language only. Typically written in high level language. That means the coding of this system calls is done in the high level languages only, like C and C++. Okay, and one more thing you can understand here is in some operating systems, these system calls can be done through the commands also, but most of the operating systems, they will not be using the commands, they will be using the APIs only. They will be using application program interfaces. So these system calls are accessed by the APIs only rather than the direct system calls. Instead of directly writing the system call, we will be using the APIs. What do you mean by using the APIs? Let us consider you have a printf statement in the C programming language. You want to print something in the C programming language. Then whenever you want to print anything onto the monitor, what you are doing, are you directly telling anything to the operating system that I want to print this one through any some sort? That sort is nothing but you are going to write this printf. This is one function. Okay, this is one function, but this function will access the system call. This function will access the interface. This function will access the system call that will allow us to perform the writing operation onto the screen. I hope now you are clear. Okay, so that's why it is called as operating system. Like these system calls are accessed by APIs rather than direct system call. See, this system call may be having some name like write like that. Okay, but we are not using write. What we are doing, we are writing printf statement. So we are calling some function in the C programming language scenario. This is called as a function. But what is the use of this function? This printf will call the system call, and it will allow us to perform the task of writing that one into the monitor. Okay, through that interface we will be telling to the operating system, that means in the kernel mode we are moving, and then the task will be performed. Okay, let us see a simple example here. What is that example is, let us try to, like, if you want to write a program to read a file and copy the contents, like copy the data to another file. Now, what we need to do here, understand, we have opened our terminal, we have opened our this one editor, and we typed the program. Now, in that program, you require one file, because you need to from file 1 to file 2. That means from source to destination you want to perform the copying purpose. Now, file 1 will be available in where it will be available? It will be available in the hard disk. Under whose control the hard disk will be? The hard disk will be under the control of operating system. That means the program whatever you have written, that will be in the you will be in the user mode only. Okay, one thing here I want to tell you, let us write down the steps first. Okay, what you will do, you have written the program, write program. Okay, let me change the color so that you can understand clearly. You have to write the program first, isn't it or not? Write program. So once the program is written, what you will do, you are in the user mode. But after writing the program, you need to save this one. But to save this program, where you need to save this program? Save this one in the hard disk. So while saving this program in the hard disk, who is responsible to do that one? Operating system only. Why? Because the hard disk will be under the control of operating system. So we need to request the operating system to assign that resource. Isn't it or not? That means writing the program is nothing but we are in the user mode. Okay, but saving the program, what we need to do? We need to move to the kernel mode. That means we need to request the operating system to do that task, right? And after saving that one, again let us see one diagram here. You can see here what is happening. Initially, before writing the program, before creating the program, this is the scenario. Let us come. There is a free space available here. Okay, and we have a command interpreter and we have kernel here, isn't it or not? I hope you are understanding. But after the program is written, that program has to be copied into the secondary memory. After copying into the secondary memory, you want to execute that program. So while executing that program, what you will do, you need to move that program from the secondary memory to the main memory, isn't it or not? Again we need to execute the kernel mode. Again we need to request that one. Again that request will be done through the system call only. So once it is moved into the, see here, once it is moved into the main memory, then it is referred as a process. I think you all can remember this one. In the last class only we understood what is nothing but process. Process is nothing but whenever the program is copied to the main memory, then the program is referred as a process. That means it is ready to be executed. Okay, that or else we can define a program in execution is nothing but a process. Okay, this copying process is also done by the operating system only. We need to use one system call to tell the operating system to do that one. Once it is copied, it has to execute that program and all step by step. Like copying, that is what our main task is. From file 1 to file 2, from source to destination, we need to copy the file. How that will be done? There are some sequence of system calls will be there. You can see here from source file to destination file, whenever we want to copy the contents, these are all the sequence of steps that we have to take care. Let us see one by one what is actually this one. Now what is the first sequence? What is the first one? acquiring the input file name. Okay, so to acquire the input file name, what we need to do, we need to first prompt the onto the screen, and then we need to accept the input. All these are system files only. Okay, after getting the input, acquire the output file. Into which file? That means this is about the source file information, and this is about your destination file information. That means you have file 1 and you will have file 2. Let us consider as an example. Okay, and after that, open the input file. This file has to be opened. That is also will be done through one system call only. If the file doesn't exist, we need to stop there. If the file exists, no need to abort. Okay, create the output file. If the file exists, abort. Okay, and then there is a loop. What is the loop? Get one character, copy into that file. Get second character, copy into that file. Get third character, copy into the file. That means reading, writing, that will be in the loop until the read fails. When the read fails, once it reaches the end of the file, once it is done, close the output file. This file should be closed. This is called as an input file, this is called as an output file as per the terminology here. Once this is done, the output file is to be closed, and then we need to get a message saying like writing operation is done. So to display this message also, we require a system call, and then terminate normally. So these are all the system calls to be executed whenever we want to copy a simple program, to copy the contents from one file to another file. So whenever there is a system call, you need to understand we are moving from user mode to kernel mode. Okay, user mode to kernel mode. We need to switch. Why? Because through this system call only we are doing that. Got it? Now we have different types of system calls. Let us see what are all the different types of system calls we have. Make a note, all of you. Let us see all the types of system calls. Okay, I'll write here. Okay, so the first type of system call is file related system call. What do you mean by file related system call? Suppose whenever you want to open a file or read a file, or whenever you want to create a file, its related system call will be done. Because opening a file from the hard disk, it will be again under the control of operating system. We need to request the operating system through the system call only. Okay, that means we can go with read, we can have open, okay, we can have write. So these are all the different types of system calls available, where file related any system call, file related any operations you want to perform, you need to go with that type of system call. Second one is device related. What is device related? Suppose you want to access some hardware, any hardware devices you want to access, then that related system calls are called to be executed. Okay, so this type of system calls are used to access hardware, okay, like let us consider you want to read data from the memory. Memory is one hardware, right? So you want to read data from the memory, or else you want to write something into that memory, or else you want to reposition, okay, or input output control, IOCTL is there. That is nothing but input output control. If you want to happen, you want to control the input output, then we need to go with the device related system calls. Okay, third type is information related. What is this information related? It is nothing but to get the information about a particular any process. Okay, process related information. That means let us consider what is the system date. Let us consider when the process is created, at what time it has been created, what are all the permissions that that process is having. Such information if you want to get, you can go with this type of system call, that is called as information related. Here you need to understand everything. Whenever we want to move from user mode to kernel mode, a particular related system call has to be executed. Okay, next type is process control. Process control related. What do you mean by process control related? That means you want to load the program from the main memory for execution, like you want to load the program into the main memory for execution, or else you want to close the execution, you want to wait for an execution, you want for about the execution, all these are called as process related. Okay, so we can say system calls like load, fork is one type of system call. We are going to learn about this one. Okay, as of now, let us not worry about that one. Fork is also one type of system call. Normally fork is used to HU multi-thread process environment. Okay, in detail we are going to learn in our future classes. As of now, this is one type of process related system call. Okay, abort, etc. Right, let us see the next one, that is communication. Communication is nothing but see, sometimes whenever we are executing multiple processes, no, one process want to communicate with the other process, which is called as inter-process communication. So that to do that one also we need to go with this system calls, that like we have pipe system call, we have create system call, okay, we have delete system call, we have connection system call. All these system calls are used, which are used for communication between the processes, which is nothing but inter-process communication. Alright, we have one more type of system call which talks about protection and security. What is the use of this system call is you want to change the permissions of the files. Let us consider from write mode you want to give only read mode. So if you want to change the permissions, okay, then you can use that particular system calls where we will be providing the security or protection to the files whatever we have. Alright, so these are all the different types of system calls we have. Whatever the thing is, the only thing here is whenever we are in the user mode, that means whenever we are using any application, and in that if you want to use any resource, okay, or any task to be done by the operating system, then we need to move to the kernel mode. So whenever we want to move from user mode to the kernel mode, any one of these types of system call, related system call should be executed, so that we can move to the kernel mode. Right? So this is about system calls. I hope you all are clear with this concept of system call, what actually a system call is, and what are the different types of system call, and with simple example. Okay, so let us all meet in the next lecture. And